Hi everybody, welcome back to the Tetrix RoboBench video series. This is Tim, and as you can see, I've got a couple of guests with me today. I've got PJ and I've got Alan, and both of those guys are colleagues with me here at Pittsco Education, and I'm going to let them kind of remind everybody, or in fact with Alan, to kind of introduce himself in what they do with Pittsco. So PJ, we'll let you start first.
Okay, I'm PJ Graham. I'm the web content specialist, and I help develop content for the websites, whether it be articles, videos, graphics, or whatever.
Okay, and Alan?
My name is Alan Kirby. I am an inside sales representative for Pittsco Education. I work directly with schools, with teachers and administrators, and putting solutions into classrooms.
Okay. Well, I've asked these folks to be here with me today because we want to talk about competitions. Tetrix has a huge role in a lot of different competitions that are held both nationally and internationally. And one of them that we are involved with is specifically Robotic Urban Search and Rescue competition. And recently there was the national event that was held in Louisville, Kentucky, and both these folks were involved. So I'm going to go ahead, and Alan has a specific role in that. So explain a little bit more about your role with this particular competition, Alan, please.
Yeah, my role within this competition is the National Technical Committee Chair. This role allows me to go into the arena and officiate the event. Okay, we have several judges that do all of the scoring and review the teams, but ultimately the competition event is mine to take care of the scoring and turn it all in.
Okay, and then PJ was this year you had the opportunity as a first-time observer, right, to go to and see this particular event.
Yes, it's actually the first time I've really gotten up close and personal with a robotics competition, and I was there just to talk to the participants and get photos and videos and stories, so it was really exciting to see what these kids did.
Okay, and PJ was nice enough to bring back some videos, so we're going to actually let you look and see some of the video that both the interviews that you did with the kids and also seeing some of the robots. Alan, let's talk a little bit about the competition itself and a little bit of background. This is a competition that's how old?
It's 51 years old for SkillsUSA.
Okay.
This competition, this is the third year of demo status, the final year.
And this is for what age groups are we talking about? This is for high school? Or?
Secondary and post-secondary.
Okay. And open to girls, boys?
Yep. Girls and boys.
Girls and boys?
Yep. Any robotics engineer or aspiring to be engineer.
And we actually, Pittsco, actually championed this competition, right?
Correct.
About 3 years ago.
Yep.
We started with how many states were as part of a demo?
We actually began running the event informally at different state conferences about 5 years ago.
Okay.
We started in Texas and Wisconsin, and just to really get a feel for how the competition would run and you know, the excitement, the involvement that could potentially be there. For the last 3 years, it's been a formal demo, and we started with a demo status of 10 states.
Okay. And this year, we'll actually, or actually I should say next year, we'll move into an official status, right?
Mm-hmm.
And how many participants statewide did we have, or states were participating in this year?
Nationwide, we had over 150 teams this year.
Okay.
It's pretty amazing. It's really grown. The number of states has grown from 10 to 14 to 18 states this year.
And we're kind of expecting similar growth for next year?
Similar growth, yeah, or more.
Awesome.
As a full-fledged event, state directors are more than likely to pick it up and offer it to their chapters.
Cool. Just a quick first-time perspective, PJ. What did you feel like when you got there and you started to see the participants and the kids and how they were reacting and everything? What's the first overview?
Well, I mean, again, I was really impressed by what they did, but the thing that really stuck out to me was that how cooperative they were. They weren't like just trying to bash each other. They were actually supportive of each other, even though they were competing against each other. And which to me seems to connect right back to the fact that skills is about building skills for the workforce. And we don't work well as interdepartmentally. If we don't work well together, we're not going to get our products out the door.
Sure.
So it reflects that to me.
Okay. Well, and I forgot to
Yep.
say, give a little bit of an overview. What actually happens in this type of competition, Alan? What's it all about? What are we simulating with this competition?
Well, the competition, first and foremost, is an engineering competition.
Okay.
Okay. The students build their robots in advance. They're engineering, testing, revising, testing, and ultimately arriving at their final robot build to compete with. The competition is based on ordnance disposal.
Okay, so kind of a very real-world connection, right? This is something
Absolutely.
that in today's society, there's a definite correlation to what actually happens in the real world, right?
That's right.
And so they have an actual event where the robot has to perform this task. But you mentioned or touched on the fact that this is not, it's a kind of a minor part of that competition in a whole. There's the game that they actually do, but then there's an engineering book
That's right.
and presentation.
That's right. A technical presentation, written test,
Okay.
and scoring rubrics based on the quality of their build.
Okay, so they actually only have about a quarter of the score, is that correct?
That's right.
I think that you told me that is involved with the actual event and the game itself. The rest of it is quite detailed as far as what they actually have to do.
Absolutely. Yeah, the way it's documented in their engineering notebook, the students must have very detailed drawings, schematics, bill of materials. Essentially, we want them to be able to hand their engineering notebook to Boeing, and Boeing could build their robot for them based off of their specs.
That's impressive.
That's highly scored.
Yep.
Mhm.
Cool. So you saw several people there, PJ. We want to kind of show some of the clips. Let's talk about one of the first ones that we want to look at. If you want to go ahead and give us a setup for that.
Sure. What the first two gentlemen we're looking at are actually the teammates from the team that ended up winning the competition, taking the gold, and they were from Massachusetts. And this is Dylan actually just talking about what it would mean to him if he got gold again, because he got gold the first time he tried it.
So this particular clip was actually prior to the competition. They didn't know
Correct.
how it was going to turn out.
They didn't know the
Just kind of
results yet.
speaking about what his expectations would like to be.
Yes.
Okay? So we'll take a quick look at Dylan.
Getting this far is just reason enough to be happy with yourself and feel accomplished. But to get the gold would solidify that accomplishment within myself and my teammates' self. And getting gold, improving upon last year's bronze, it just solidifies that we improved upon last year in what we needed to do. And we successfully accomplished that in a robot if we place gold this year.
PJ, go ahead and set up the second clip for us.
Okay, and the next one is Tony, also from Massachusetts, and you know, he just really, he's a very well-spoken young man, and he just had a lot of great things to say about the competition, what they learned.
Okay, so these were teammates, Tony
Yes.
and Alan, or
Yes.
Tony and Dylan, forgive
Dylan.
me. So we'll see what Tony had to say.
It's just a great competition, honestly. I get freedom to build what I want, to do as much research into EOD as I want. It's something that it's not necessarily lifting up boxes and putting them down. I'm looking at an actual problem that's faced by people today, and I'm trying to find a solution that I can come up with. And just the fact that it's applied makes it so much more interesting and so much easier to get overwhelmed with and get into.
One interesting story that I have about the team from Massachusetts, the first time I met these young men was actually in Massachusetts for their state conference, I believe 2 years ago. It was about 2 weeks after the marathon bombing had happened in Boston, and the TV was still plastered with images of the robot searching for the young man in the back of the boat and digging him out. And this was, so you were talking about real world connections. That was a real life event, and they were conducting this contest looking for simulated ordnance just weeks after.
Yeah. So very relevant to what we see in our
Absolutely.
sometimes on the news. That brings up a point that some of these kids have been involved for several years.
Yes.
So this is not just a one-time flash in the pan. They come back and do this year and again. So PJ, go ahead and set up this third clip for us.
Okay, this is Jonathan from the team that ended up being in second, Tennessee. And he was really just talking about, in this clip, about how sometimes he they learned that going simpler was better than becoming more complicated.
And I thought as I watched this clip that that's a very relevant concept to learn, an important concept to learn as an engineer. Sometimes we get overly clever in what we try and do with things, and simple actually is better. So it's interesting to see they discovered that on their own.
Pretty hard because we had quite a few failures, but I guess seeing it change from something really difficult to something a lot simpler but will work the same way, that was really neat to see.
Okay, and the last clip for us?
The last clip is the team from Idaho, which, again, they took third. All these were done before the results were known, so it's kind of ironic that I talked to the top 3 teams, Matt and Catherine, and they're just expressing what they love about this event.
Okay, let's see what Matt and Catherine have to say.
What would it be? It's awesome.
It's definitely worth all that long hours.
All the work and time and effort and everything that we put into it is well worth coming here and being able to see ourselves succeed and other people.
Excellent.
Okay, one of the things that I found interesting is that it's not just boys involved in this competition. There were a lot of females involved. You had mentioned that in some of the states there actually are all-girl teams. Now, I don't know that, did you guys see any all-girl teams at the national level?
No.
Not,
We did not.
all-girl, but there were several teams that were mixed with boys and girls.
Correct.
So we want to show, I think, PJ, go ahead and set up this next clip because we want to show, I think, that some of the female
Yeah.
point of view.
Well, and at the Nationals, there weren't a lot of girls. There were really only 3 or 4 there.
Right.
But it's interesting to point out that 2 of the top teams each had a girl. So girls shouldn't be dissuaded about joining this competition just because there aren't a large number yet.
Okay.
And I think Savannah
Yet.
from Tennessee has some words to say to encourage them.
Okay, let's see what Savannah had to say.
I think more girls should do it because some of them they think, oh, it's robots or oh, it's vocational stuff that you shouldn't do it. But I think girls can do it just as well as guys can. So I'd tell them to do it. It's really fun, so I would do it.
So we've seen some of the interviews of some of what the kids had to say. Let's look at for a minute at some of the robots because I was very impressed with the level of engineering that the kids and thought that the kids had put into their robot designs. Unlike some of the other competitions out there, this is one that since there's no robot to robot contact, the kids were really, I think, and it was evident in what we saw, be able to focus on what the really task was and what design they had, changes in engineering they had to do in order to accomplish that specific task at hand. So I was very impressed with the level of engineering in the robots. So this first one, again, PJ, you want to go ahead and set up what we're going to see?
This is part of the run from the Massachusetts team, Dylan and Tony. And they said that the thing they had learned from last year was to make the robot a little smaller. So you can see that they've got a more compact robot than some of the other teams.
So this first one is the actual winning team
Yes.
that took gold. Again, kind of demonstrating the fact that maneuverability and speed sometimes win out over size and strength,
Right.
and somehow one can impact the other, right? Okay, so let's see what the robot did.
down.
So, Alan, what were your impressions on the Massachusetts robot?
Very well engineered bot. They've definitely taken their years of experience and put it into the development of this year's robot. One thing that may remain unseen is the engineering that has to go in due to the limitations of the contest. The overall bots are limited in size. They're also constrained by the number of motors and servos that they're able to use. The camera platform is open-ended, so they can use a variety of different cameras. What was interesting about Massachusetts Robot was that they used an automotive backup camera, which gave them a much better depth of perception and much better or wider angle of view.
Okay.
Very important on a limited size of robot.
So let's go ahead and just, since you're talking about that, let's go ahead and explain that the competition is not platform specific as far as just Tetrix. Obviously, Tetrix is important to Pittsco because that's our product, but this particular competition doesn't restrict entrants to just the Tetrix material. They can
Right.
They can use, like you mentioned, cameras from different manufacturers. They can use raw material of different types.
Right.
They can even 3D print material,
Correct.
right?
Correct.
Okay. So that kind of helps kind of set a context for what they're actually able to use in the competition.
Right.
PJ, you want to go ahead and set up this next robot that we're going to look at?
Sure. This is the Idaho team, Catherine and Matt again. And I think what you see here is a really excellent gripper at work. Because I believe, if I'm correct, Alan, that they were one of the fastest teams to get through the course.
They were the fastest team at Nationals to get through the course.
And they did print their own gripper, 3D print?
They did.
Okay. So let's look and see what the Idaho team's robot looked like and how it behaved. Okay. PJ, tell us about this next robot.
This is the Tennessee robot with Jonathan and Savannah. And this one, I think most people notice about it is the suspension, especially in the clip we're going to show where it's actually coming up the ramp and turning corners and maneuvering in ways that you normally don't see from these robots.
And this, just to give reference to, I think Savannah, it was interesting to see her take on the fact that she was looking forward, I think, coming back next year and revising the suspension. Is that right?
Yes.
Okay, so let's see what their particular robot looked like and how it behaved. Okay, in this next clip, PJ, what are we going to look at?
Well, and I actually don't know which team this was because I didn't catch the number on it, but it had a very interesting gripper, and I just wanted to show it just because it was so different. It used 2 wires that looped out to grab, and they could pull them and tighten them and loosen them, and then the whole arm could rotate like that.
Like a wrist?
It was just kind of different and unique, and I thought it was something interesting to show that it's not always the traditional gripper idea that could work.
It
But
shows that innovation, it plays an important part in this, and sometimes those people that think outside the box are rewarded by that. So let's see what this particular gripper looked like. Okay, so thanks, guys. I tell you that it looks like it was an amazing event. Looks like the groups all had a good time, and looks like that they did some very impressive work. Anything that you guys want to add as we kind of wrap this up a little bit about thoughts about the competition? What do you think this means to kids when they have a chance to do this type of event? Alan, do you think it impacts their lives?
Absolutely, yeah. SkillsUSA has taken great pride in their students that are competing are gaining life skills, not necessarily the soft skills that they learn by teamwork and camaraderie, but the engineering trade in general. They're learning specific skills through that competition and through the challenge leading up to it that they can take with them into the career fields.
So this is something, the life skills that they're gonna use later on in everything they do.
Yep.
PJ, final thoughts from you. What did you think after, again, maybe a first timer to a competition like this?
well, and to build on what Alan had said, learning. When I was talking to all the students, one of the things that came up frequently was that, yes, sometimes they fail, but they learn as much from the failure. I mean, even the students who didn't place in this event, I think probably learned a tremendous amount. And a lot of them are going to come back with even better bots next year.
That's great. That's great. Well, again, we appreciate you taking time to visit the RoboBench video series, and we hope you found this interesting. We hope you'll have fun building those robots and come back and see us.